Hey, this is Mr. Calbeck here. I just excited to see you guys today. Um, just wanted to wish you well on your test if you've already taken it. Congratulations. Most of you did really well, it seems like. So nice job there. We're going to be starting a new chapter today, and we're going to be dealing with radicals. So radicals is just another name for a square root. So just wanted to get you guys going on that here today. Okay, so it's another name for a square root. Um, but first, let's talk about how we have solved these in the past, and we'll talk about a couple of things in the ways that we've used them before. So before everything went crazy and you guys were solving stuff, we had quadratics or parabolas in vertex form. So you'd have something like this. And maybe I would write something like this. Okay, so here'd be a vertex form equation. Now, we've spent a lot of time graphing these, and a lot of you are wondering, Mr. Calbeck, how do you go about finding the x-intercepts for this? Because this is not in factored form. You cannot do the zero product property because of this little dude right here. When you're subtracting something there, it doesn't work. But you can actually just use algebra to find the x-intercepts for this. X-intercepts, remember, happen in any parabola. They always happen wherever they cross the x-axis, which always happens when y equals 0. Okay, whatever these coordinates are, I may not know what the x-coordinate is, but I know that the y-coordinate has to be 0 for these guys right there. So what we can do is we can plug 0 in for y, and we can see if we can do some algebra with this. So a couple things here. Let's do the opposite. And you actually want to do Pemdas backwards when you're solving these. It'll make your life a lot easier. So Pemdas normally tells us that we start with parentheses, then go to exponents, multiplication, division, addition, subtraction, etc. But in this one, we're going to start backwards because we're undoing the problem. Because we're trying to solve for x, we're going backwards. We want to do PEMDAS backwards as well. So it starts with subtraction. We're going to go ahead and start with subtraction as well. We're going to add both sides. We're going to add 4 to both sides. So we get 4 equals x plus 2 squared. Now we can follow PEMDAS. There's no addition that's not in the parentheses, which we would do last. No division or multiplication. There is an exponent though. So let's go ahead and see if we can undo the exponent. The exponent is squaring the entire side. And remember the golden rule. You guys have to follow the golden rule. So we want to square root both whole sides, which leaves me with 2, not quite. But it will cancel this out here, give me x plus 2. What this does do is, essentially what we're trying to do with this problem is we're asking ourselves, what number, again, this whole thing is squared, right? So we had x plus 2 squared equals 4. So we're asking ourselves, what number squared equals positive 4? Again, it doesn't look like a number, but x plus 2 is just some number. We don't know what it is. So again, 2 works because 2 squared works, but there's actually a second answer. Negative 2 squared also equals 4. So we actually end up with 2 perfectly good answers here for x. We have positive 2 and negative 2. And usually the way that we write this is plus or minus 2. Anytime you're taking the square root of x squared, you have to take, when you take the square root of that, you have to remember there's a plus or minus in the answer. And all that means is there's 2 separate equations. We've done this before with absolute value. One of them is positive. So I have positive 2 equals x plus 2. And the other one is negative 2 equals x plus 2. And then we could solve both equations and find our x-intercepts. we can subtract 2 here, and we find that one X-intercept happens. Oops, let me move this. One X-intercept happens when X is 0, and the other one happens. Sorry, I got to subtract 2 from both sides. See if I can do the opposite here. You're going to give -4 equals X. So I have 2 X-intercepts there. And this is how we've seen square roots happen before. Unfortunately, though, sometimes they don't always come out so neatly. And you guys have seen this plenty of times with problems, and you're like, wait. So how do I do this when it doesn't come out neatly? And you've seen answer keys where the X-intercepts appear to be directly in between two numbers, but it's not even like a half. It's like just this weird in-between number. Okay, so let's talk about a couple of other possibilities for this. Let's say we had the same kind of equation. I'll give you another one here. Excuse me. Okay, so here's another possibility for this. If I wanted to find the X-intercepts of this, again, I would expect you to be able to graph this, and most of you are doing a great job with that. But if you can't graph it, we can still find the X-intercepts by plugging in 0 for Y. And we're going to do Pemdas backwards again. I'm going to start by adding 10 to both sides. 0 plus 10 is just 10. Now we're done with addition and subtraction, but there is multiplication. This 2 in front here is multiplied. Whenever you see a number next to something and no symbol between, that means multiplication. So 2 times this, I'm going to divide both sides by 2. You end up with 5. 5 equals X minus 1 squared. And we'll do the same thing as we did before. Take the square root. And we do remember this. Anytime you take the square root of X squared, you need a plus or minus. So I have this answer here. Whatever the square root of 5 is, I know that that has to be plus or minus. But square root of 5 doesn't come out even. So is this no solution? What's the deal here? And it's a really strange question. Now you can type it in your calculator, and that will actually give you an answer. You can go ahead and type this in. The square root of 5. Square root button is the second function of your x squared, so hit second x squared. It'll give you this number right here. Doesn't seem to make any sense. It's an irrational number. If you remember what irrational numbers are, they're numbers that cannot be written as a fraction, which means that the decimal point will go on forever, never terminating, which means it never stops, and it will never repeat. Okay, the most famous irrational number is pi. Square root of 5 is similar to pi. So now we have this weird number here, and you can just leave it like this. That's fine. If I want to solve this, I have to set up two equations like I did before. One of them where the square root of 5 is positive, so square root of positive 5 equals x minus 1. And the other one where it's negative. So I have a negative. And you can put that a -1 in the front there if you want. Equals x minus 1. So we got to figure out how to solve this. You can add 1 to both sides. Remember, this is an irrational number. So square root of 5 plus 1, whatever that equals x. And then over here, I'm going to add 1 to negative, which would be, let's see, let's move it around the other way. So put 1 over here minus the square root of 5. So those are my two x-intercepts. And this is really the question we're trying to answer here. Does this simplify? Does this make the square root of 6, for example? We can try that and see, because I can just add 1 to this number and see what it would equal. 3.23. Let's see what the square root of 6 is. Square root of 6 is 2.4. So it's actually not correct. As it turns out, you cannot add square roots in other numbers. You can't do it. So this is as simple as it gets for that answer. It's the exact answer. You can also write the decimal approximation, which in this one would be 3.23. The other one, whatever that would be. That's fine. 2 decimal points, please, if you write the decimal approximation. So that's great to start with. So we know that square roots, you can't add them to other regular numbers. What about other square roots? What about square root of 5 plus the square root of 3, for example? Could I add those together? So again, what we're looking at here is we would have the square root of 5, which we've already seen, and the square root of 3, which is 1.7. So is that the same as the square root of 8? Let's try it. Square root of 5. Make sure you get out of your square root there, plus the square root of 3 is 3.9. Let's see what the square root of 8 would be. Not the same answer. So it turns out you cannot add square roots and other square roots either. That does not equal the square root of 8. Okay, what you can do, the only way that you can add square roots or subtract them is if this is exactly the same number. So I could add the square root of 5 plus another square root of 5. And what that would equal is 2 times the square root of 5. You treat them just like a variable. Or you could have something like this, like another one, square root of 11 or something. So you'd have 3 times the square root of 11 plus another square root of 11. That would equal 4 times the square root of 11. So you can add square roots only if they have the exact same number underneath the square root. Okay. There are other things you can do with them, though. There are a few things that you can do with square roots that are legal. You can multiply square roots together. So, for example, I could take the square root of 2, another irrational number, and multiply it times the square root of 3, and that will equal 2 times 3. So you can multiply them. That's good. So you can multiply square roots. You can divide square roots. The square root of 8 divided by the square root of 2 does divide. Again, the square root of 8 and 2, you just divide 8 and the 2 together. That's the square root of 4. And actually, the square root of 4, we know what the answer to that is. It's actually 2. Okay, so we can divide, that's legal. We can multiply, that's legal. And we can simplify when there's whole numbers. Okay, but sometimes there's some weird situations where you can actually reduce square roots that are just a little bit bigger. And I'm going to show you how to do that, and we're going to use this strategy to hack them. Okay, so let's take a look at something simple that doesn't look like it comes out even. The square root of 8. We know the square root of 9 is 3, the square root of 4 is 2, but square root of 8 doesn't come out even, and we just saw that number here on our calculators, 2.828427125. Irrational. We can, however, simplify this to make it a little bit smaller and easier to work with. And the first thing that we're going to do is you're going to remember that I'm allowed to multiply and divide square roots. So what I want to do here is say, what square roots, now here, hold on a second, spoiler alert. I want to say, what square roots are going to multiply together to give me the square root of 8? Oh, hold on. Sorry, they cut out there for a second. I want to know what square roots multiply together to give me the square root of 8. And there's a bunch that you can pick here. But I'm hoping that you saw that I could fit in here. Square root of 8 equals the square root of 2 times the square root of 4. Correct? Because I can multiply square roots together, and that equals the square root of 8. But there's something really cool about writing it like this. We actually know what the answer to this one is. The square root of 4 is equal to 2. So the square root of 2 times 2, And generally, when we're multiplying numbers, we put the regular number in the front of the square root. So I'm going to put that here. I do 2 times the square root of 2. And that is equal to 8. And we're using that because we are allowed to multiply square roots together. And you can always check your work. So remember, previous answer, the square root of 8 was 2.8. You can also try 2 times the square root of 2 and see if that gives us the same answer. 2.8. Notice all these decimals line up exactly. If there's even one off, you did something wrong, but it's a great way to check to see if you simplified correctly. And you can actually do this with any number. Not all of them will simplify perfectly, but a lot of them will. Stuff that you wouldn't necessarily expect simplifies. For example, let's try another one here. I could simplify the square root of 45. Now, I wouldn't necessarily be able to figure out what that is by looking at the number. It looks irrational if we type it into our calculators. That's right. It looks irrational if we type it into our calculators, and it is. But we can simplify it. Think about it as like a fraction. Fractions simplify. We can simplify square roots as well. So I want to say, okay, what times 45? What two numbers will multiply together to be 45? And what we're looking for here is something called a perfect square, something that simplifies perfectly. So try to think of two numbers that multiply to be 45, and one of them is a perfect square, something that will simplify. I'll give you a second to try to figure it out. Hopefully you came up with two numbers here. Square root of 9 times the square root of 5. Now the square root of 9 is a perfect square. So what I can say is this is equal to 3 times the square root of 5. So I could say that the square root of 45 is equal to 3 times the square root of 5. All right, and we can, again, check our calculators and make sure that we got this right. I want to see if 3 root 5 is also equal to that same number. And it is. And again, notice every single digit lines up. Okay, now that's the simple idea for reducing square roots. Sometimes, though, you're not necessarily going to be able to figure this out in your head. If you can, though, please do it. Feel free to take those shortcuts in your head. But some of you might be like, Calbeck, that's great. I love that you are asking us to multiply again, and I was not great at it in factoring, and I'm still not great at it now. So I'm going to teach you guys a strategy that you can simplify any square root, even if you don't see the answer beforehand. Okay, so I want to show you something here. So we're going to take a bigger number. We're going to take the square root of 80, and we'll practice with that. Okay, square root of 80. Now, you might be able to come up with two numbers that multiply, and one of them is a perfect square, or maybe you wouldn't, and that's okay. This one's a little trickier, and you might get stuck with it. So, actually, let's do something a little smaller than square root of 80. Let's do square root of 40. Square root of 40 is a little easier to do in your head, too, so we'll do that one. We'll come back to square root of 80 in a minute. So, square root of 40, I want you guys to break this up, and we want to factor it. I want you to come up with all of the multiples of 40. And what we want to do is find prime numbers that divide into the square root of 40. And we're going to have more than one square root here. So let me show you what I mean. I want to think of the smallest number I can divide evenly into square root of 40, or into 40 that's not 1, because that's boring. So I'm going to pick 2. And I'm going to make a little factor tree. You guys did this in elementary school, so some of you might be used to it. However, but now we're going to do it with square roots. So I know the square root of 40 is the same as the square root of 2 times the square root of 20. All right. Now, square root of 2 is boring because it's a prime number. It's only divisible by 1 in itself, so I'm going to leave that one there. Now I'm going to do the same thing with the square root of 20. I want to pick the smallest number I can divide evenly into 20. It divides by 2. 2 times the square root of 10 gives me 20, right? And I'm going to keep doing this until I have all prime numbers left. And I'm going to take the same thing. 10 is divisible by 2. So the square root of 2 times the square root of 5 is going to multiply to be 10. Now what I've done here is I have made a factor tree. I have a prime factorization of 40. Essentially what I've done here is all these numbers, 2 times 2 times 2 times 5, these outside numbers are all multiplied together to be 40. And you can check it if you want to. The square root of 2 times the square root of 2 times the square root of 2 times the square root of 5 is equal to the square root of 40. Those are exactly the same. Now, here I'm going to show you why I want to do this. Okay? There's some really cool things when you have the same square root multiplied by itself. So let's forget all this other stuff here for a second. Let's just multiply the square root of 2 times the square root of 2. See what happens here. So the square root of 2 times the square root of 2 equals what? You can multiply square roots, so it equals the square root of 4. What's the square root of 4? Square root of 4 comes out even. It's 2. Every time, this is a pretty cool thing. The same number ends up essentially canceling out the square root. The reason that it does this, square root of 2 times the square root of 2 is the same thing as the square root of 2 squared. And what do squares and square roots happen? They cancel out. So that's going to equal just a plain old 2. And this is a really neat feature. Anytime you see the same square root show up twice, it will cancel out the square root and leave you with a number underneath. So let's see what happens here. The square root of 2 times the square root of 2 is square root of 4, but this just cancels out and gives me 2 because this is the same as square root of 2 squared. These two multiply together, square root of 2 times square root of 5 equals the square root of 10. And you can check your calculator. The square root of 40 simplifies to 2 root 10. So if you want to simplify a square root, all you need to do is make a prime factorization, make a factor tree, and find a pair of numbers. Okay, let's do that again, and we'll try another number here, and then I'll let you guys go ahead and try your homework and practice. Okay, so let's try something a little bit trickier, a little bigger number. Let's do square root of 90. Okay, again, some of you may see the special factors of these, and if you can think of two numbers and one of them is a perfect square, feel free to do this trick. But if you can't, let's make a factor tree. Okay, they both work. It's a great method. Your calculators, however, are not going to be able to do this for you, other than to check your work at the end. So let's think of the smallest number that divides evenly into 90. That would be 2. So I'm going to make my factor tree. That's the square root of 2. Square root of 2 times the square root of 45 gives you 90. Cool. Now 5, you could try to find some numbers that divide there. And it honestly doesn't matter if you get the exact smallest or not. Just make sure that it's a prime number. So for this one, the smallest number is actually 3. But you might have chosen 5 or something else too. That's fine. Square root of 3. And that's times the square root of 15. And over here, the smallest number divides into 15 is the square root of 3, which gives me the square root of 5, and I'm done. I have a prime factor tree. So that means that 2 times root 3 times root 3 times root 5 equals the square root of 90. Now we want to find if there's any pairs of numbers here. So if root 2 times root 3 times root 3 times root 5. Is there any of these numbers that are the same? Because if they are, they will cancel that square root out. And you see in the middle here, the square root of 3's are the same. Square root of 3 times square root of 3 is this. Oh no, is this right here. So what happens to the square and the square root? These cancel out, leaving you with just a 3. So that I'm going to bring the regular number out in front. Remember, whenever we're writing regular numbers here, the numbers that don't have the square root go in front. So I'm going to go ahead and put the 3 in the front. And then I'm going to multiply 2 times 5 to get root 10. Okay, now again, you might have seen this at the beginning. You might have said, oh, square root of 90, that's the square root of 9 times the square root of 10. And the square root of 9 is a perfect square, which gives you 3 root 10. That's the short way, but it's more challenging, and the bigger the numbers get, the harder this is to do. So this gives you 3 root 10 as well. Either way will give you the same answer. All right. I just want you guys to practice simplifying these. I'm going to give you a few problems to solve. And so you're going to be solving square root problems and simplifying the square root answer when you are done. Okay. It's a worksheet. Check your answers. Shoot me an email if you have any questions. And we're going to get going on this. I hope you guys have a super day.